Let's talk about bonding and let's focus on metallic bonding. We want to be able to describe what a metallic bond is and explain how metallic properties such as thermal conductivity, electroconductivity, malleability, and ductility arise because of metallic bonding. So, what is metallic bonding? These are bonds between metal atoms only. And so remember that metal atoms are trying to give away electrons. But if there isn't a nonmetal there to accept the electrons, then the metal atoms end up passing electrons from one metal cation to another, and these electrons just kind of float around between all the different metal elements. And we call this becoming delocalized. So the electrons become delocalized, and that means they're not stuck in one place and that they're moving freely. Matter of fact, the fact that they're moving is going to be important for describing all of these properties. And collectively, or the term that we use for this is that in metallic bonding, we have a delocalized sea of mobile electrons. Again, delocalized means that the electrons are all over the place, and mobile means that they're moving. And we kind of have this picture of electrons flowing from one atom to another atom. And so this is metallic bonding. It's a delocalized sea of mobile electrons, and because those electrons are all negatively charged, they hold all the positive cations in place. So, what are the properties of metals? We've talked about this before, and we know that metals are good conductors. And that means that they're able to transfer heat and electricity well. And this is because of two things. Number one is the delocalized sea of mobile electrons. Since the electrons are already moving, it's very easy for electricity to flow because electricity is the movement of electrons. Now, the other thing that makes good metals good conductors of heat is that the atoms are all really close to each other. And so they are vibrating in place and they're able to bump into each other and transfer lots of energy whenever the one side of the metal starts getting energy. Metals are also malleable. And this means that they can be shaped. We can change the shape of a metal. Imagine a piece of aluminum foil. You can bend it and fold it and mold it into a statue, even. And this is because the sea of delocalized electrons is able to move and change its shape. And so imagine if I hit a block of metal with a hammer, what ends up happening is I just change the shape of the sea of delocalized electrons, but it's all kind of still staying together. For this, I kind of imagine Play-Doh, right? If you take Play-Doh and you hit it, it changes its shape, but it still stays together. Now, I can hit metals enough to cause them to break, and that would be deforming it beyond its limits. But metals are extremely malleable. And then the last property of metals is that they're ductile. And this means they can be pulled into long wires because the sea of electrons will keep stretching and holding them together. And eventually they will snap. And that's whenever the sea of electrons becomes too thin. So, recap very quickly, metals have the properties they do because of the delocalized sea of mobile electrons. And this is metallic bonding.